Hello, this is Farhan Shakil from the Republic 2.0, and we're back with the second part of 2025 Edexcel Peer 1. So we're going to restart from the question number 6. The first 5 questions have already been uploaded. So we'll restart with question number 6. And the question number 6 says that the curve has equation f of x where x is greater than 0, given that the point lies on the curve, and f of hash x is 2x square plus ax plus b divided by the 4 root of x, where a and b are the constants. The gradient of the tangent at c is, at p is 7. So we're just going to plug that point P into this gradient, keep the gradient is equal to 7. We'll simplify that equation and we'll see what the equation comes up. We need to prove 4a plus b is equals to 24. So first of all, given derivative is f of hash x is equals to 2x square plus ax plus b divided by 4 root of x. So you've got 4 root of x. So at point P, which is 4 and negative 7, at point P, which is 4 and negative, let me just recheck that. Yeah, it is 4 and negative 5. So at this point, you've got 4 and negative 5. The tangent is 7. So I'm just going to replug all these values. In the place of derivative, I'm going to write 7. And, I'm going to plug the 0.4 and negative 5 into this derivative. So 2 times 4 square plus a times 4 plus b as it is divided by 4 root of 4. And now I'm just going to simplify that equation down. So 7 is equals to 4 square is 16. 16 times 2 is 32 plus 4a plus b divided by 4 root of 4 has to be 4 times 2 is 8. So it has to be something like this. And now, you've got 7 is equal to 32 plus 4a plus b upon 8. I'm going to multiply 8 on both the sides. And I would be having 8 times 7, which is 56, is equals to 32 plus 4a plus 4b. Now I'm just going to flip these equations over. So I would be having 4a plus b is equals to 56 minus 32. And that would eventually become 4a plus b is equals to 56 minus 32, which has to be something like um, 8, 8 and 16, yeah, 24. So that is the first equation that we were looking for. You can see that, right? We've just got to prove that. Now it is also given that a plus b is equals to negative 9. So if a plus b is equals to negative 9, we need to find the f of hash x in the simplest form. So first of all, by using both of these equations, I'm going to find myself the values of a and b, right? So in the second part, since a plus b is also equals to negative 9, right? The value of a from here could be negative 9, negative b. I'm just going to replug that value in equation number 1. So 4 times a would be negative 9, negative b plus b is equals to 24. I'm just going to solve it down now. So 4 times negative 9 has to be negative 36, negative 4b plus b equals to 24. And from here onwards, I would be having negative 3b is equals to 24 plus 36. And now everybody can see that the value of b from here has to be negative 3b is equals to 24 plus 36 would be something like 60, and b would be something like negative 20. And once I've got the value of b, I'm just going to plug that value of b into this equation to get myself a. So a is going to be negative 9, negative b. So that would eventually comes out to be a is equals to 11, right? So the function that we were looking for, you know, so now f of hash x is going to be, if you remember, we've already got the derivative and that was 2x squared plus ax plus b divided by 4 root of x. I'm just going to plug in the values of a and b. So I'm just going to write 2x squared, 2x squared plus ax plus b 2x square plus ax, a is 11x and b is negative 20. So I'm just going to write it over here. And the whole divided by, it was 4 root of x. So I'm just going to rewrite it like this. It would be 4 root of x now. And now I'm just going to solve it down. So first of all, I would be having f of hash x is equals to 2x square divided by 4 root of x plus 11x divided by 4 root of x minus 20 divided by 4 root of x. I'm just going to simplify it down, and I would be having 1 by 2 x to the power of 2 minus 1 by 2 plus 11 by 4 x to the power of 1 minus 2 minus 5 x to the power of negative 1 by 2. So finally, the derivative would look like you would be having something like 1 by 2 x to the power of 2 minus 1 by 2 is something like 2 2s are, yeah, it is going to be 3 by 2 plus 11 by 4 x to the power of 1 by 2 minus 5 x to the power of negative 1 by 2. Now everybody knows that if you want to get a function from here, all you need to do is to just integrate both the sides. So I'm just going to integrate both the sides, and I would be having f of x is equals to 1 by 2 x to the power of 3 by 2 plus 1 divided by 3 by 2 plus 1 plus 11 by 4 x to the power of 1 by 2 plus 1 divided by 1 by 2 plus 1 minus 5 x to the power of negative 1 by 2 plus 1 negative 1 by 2 plus 1 and plus c. So I'm just going to solve it down now. So I would be having x to the power of 5 by 2 divided by 5 by 2 plus 11 by 4 x to the power of 3 by 2 divided by 3 by 2 minus 5 x to the power of 1 by 2 divided by 1 by 2 plus c. So I would be having something like this. And now you can cancel out this 2 with this 2 with 2, and this 2 times 5 would be 10. So I would be having f of x is equals to 1 by 5 x to the power of 5 by 2. And then over here, I would be having plus 11 by 6 x to the power of 3 by 2 and negative 10 x to the power of 3 by 2 plus c. Now, you've got P, the point P, it was lying on the curve. If point P was lying on the curve and that was 4 and negative 5, you just need to plug this point in that function to get yourself C. So you've got 4 and negative 5. So what are you going to do? Negative 5 is equals to 1 by 5, 4 to the power of 5 by 2, plus 11 by 6, x to the power, 4 to the power of 3 by 2, minus 10, 4 to the power of 3 by 2, plus C. That is something like, 5 by 2. Yeah, sorry. It has to be 1 by 2, no? So it would be 1 by 2, right? And over here, it is going 3 by 2, and this is 1 by 2 as well. Now, by just sorting it out, all these things, if you get the value of C from here, the value of C from here comes out to be negative 91 upon 15. So replug this value of C into this equation, and you'll get the final value of your function. So f of x is going to be f of x is going to be 1 by 5 x to the power of 5 by 2 plus 11 by 6 x to the power of 3 by 2 minus 10 x to the power of 1 by 2 minus 91 upon 15. So that is how you'll get yourself the final function. Now, if you go back to the question, curve C is transformed to a curve y is equals to f of x minus 3. Point Q is transformed to a point Q. So you can see that transformation is 3 units towards right. So initially P was something like 4 and negative 5. So if it is 3 units along right, you just need to add this 3 into the x coordinate, and you would just be having 7 and negative 5 as the final coordinates of Q for the C part. So that is how we are supposed to do the question number 6. Now, after this thing, we've got something like question number 7. The curve has equation y is equals to 2 upon x minus k, where k is a positive constant. And then we need to sketch the curve of C. So, and on your sketch, we need to show the coordinates of any points of intersection C with the coordinate axis and the equation of the horizontal asymptote of V, stating each term in terms of K. So what are we going to do? First of all, we just need to sketch that, right? We're just going to sketch the curve of this thing 2 upon x minus k. We already know that without negative k, 2 of x, 2 upon x should be lying in the should be lying in the should be lying in the first quadrant, right? First and the third quadrant. So you would be having, for example, if you look for the coordinate axis, all you need to do is to given curve. Given curve is y is equals to 2 upon x minus k, right? So you just need to plug in the value of y as 0 to get yourself the x-intercept. So for x-intercept, you would be having 0 is equals to 2 upon x minus k. And at the end of the day, it is going to be k is equals to 2 upon x, and x would be 2 upon k. Now, that is going to be the equation of the intercept of the x-axis. And apart from looking for the equation for the x-intercept, the other thing that we're going to do is to look for the equation of asymptote. And equation for asymptote, everybody can see that it has to be y is equals to negative k. So if you want to plot it down, the graph of this equation would look like, for example, this point is negative k, and somehow this point has to be 2 upon k. So I've got myself the x-intercept. I'm just going to redraw it like this, right? This is the equation of asymptote. And then the downward equation might look like this. When you're going to plot it with proper scale, it would be a much better thingy. Okay, so that is how we're going to sketch this thing. So we're done with the first part. Now we've got another line which has an equation y is equals to negative kx minus 6. And we are given that the I intersects C at two distinct points. So find the range of the possible values of k. So what are we going to do? We just need to keep both of our equations equal to each other and get the value of k, right? So for the second part, since L1 and L2 intersect at two distinct points, so you just need to plug these values in. So you've got y is equals to 2 upon x minus k. Y is equals to 2 upon x minus k is equals to, the other equation was y is equals to negative kx negative 6. So I'll just create negative kx negative 6. So with this equation, you know what I'm going to do? I'm just going to create a combined quadratic equation. So I would be having something like 2 upon x is equals to negative kx negative 6 plus k. And I'm going to multiply that x on both the sides. So I would be having 2 is equals to negative kx square negative 6x and plus kx. And right after that, I'm just going to move this kx square over here. I would be having kx square plus 6x minus kx plus 2 equals to 0. And I can rewrite that equation, which would look like kx square plus x times 6 minus k and then plus 2 equals to 0. Now, since it is given that both the lines are intersecting at 2 points, so what does that mean? That their discriminant has to be greater than 0. So both lines intersect at two distinct points. So if they are intersecting at two distinct points, what does that mean? That their b square minus 4ac has to be greater than 0. So I'm just going to replug my values. My b was 6 minus k square. the A was, K, and the C was something like 2. It has to be greater than 0. So now I'm just going to solve it down. And I would be having 6 minus k square, which has to be 36 plus k square minus 12k minus 8k greater than 0. And I would be having k square minus 20k plus 36 greater than 0. So I've got this thing, right? And you would be having something, since we need to get the factor, so I can rewrite it as k minus 18 times k minus 2 greater than 0. So k has to be greater than 18 and k has to be greater than 2 as well. So that is how you'll get yourself the final values of k. So that was it. This was question number 7. We have got ourselves the curve as well as the values of k. Now we're going to get to the next question. And in the very next question, in question number 8, you can see that you've got this sort of a triangle OCBA. Figure 1 shows a sketch of the design for the badge, and you've got the angle over here as pi by 6. You've got AB, you've got the opposite side of pi by 6, and you've got this 3.4. And what are you looking for in the very first part? Find the size of the angle OAB. So we are looking for this side. Now you can easily see that this is a triangle, right? Obtuse triangle. It do not have any sort of a 90-degree angle. And if it do not have any sort of a 90-degree angle, what does that mean? Just so, we need to find out this angle, and the opposite side of this angle is given. And we also need to find out, this angle only for now. So you've got this triangle. So you can just simply apply the sine rule to get yourself this angle, right? Side, you know, sine pi by 6 divided by the opposite side, and that is 1.9. And then sine angle of OAB divided by the opposite side, which is 3.4. So by just sorting it out, you need to times it by, if you need to look for angle OAB, it would just be uh, 3.4 multiplied by sine pi by 6 divided by 1.9 and sine inverse of this thing. And whenever you're going to calculate the inverse of this thing, you'll come out with, in radians, you'll get 2.034 radians as the final angle. So that is how you'll get the angle at OAB. Now, we need to find the area of the triangle OAB in centimeters square, giving it answer to 3 significant figures. So the good thing is that, we have got this angle. We have got this angle. If this is a pi by 6 something, and if this is something like 2.034, so in radians, so this angle has to be something like, so angle at OBA has to be something like pi minus pi by 6 minus 2.034. And the angle at OBA comes out to be, if you just solve it down, you would just be having the angle as the pi minus pi by 6. Let me just see that. Pi. So you've got this angle, that's OBA has to be pi minus pi by 6 minus 2.034. You can solve it down and you'll get the answer in radians. And now we need to get the area of triangle OAB. So area of triangle OAB would be 1 by 2 times them by the opposite sides. You've got this 3.4 and 1.9 and the angle in between them. So just times them up and you would be having times that by 3.4 times 1.9 times sine pi minus pi by 6 minus 2.034. So when you'll be solving it down, by just using your calculator, the final area of the triangle OAB comes out to be something like 1.78 centimeters square. So you're done with this, area. Now, given that the ratio of the area of sector OBC to the triangle OAB is 3 by 2, show that the angle BOC is 0.462 radians to three significant figures. So first of all, how would you get yourself the area of sector OBC? Well, if you look for the area of sector OBC, OB, OBC, you've got this, you've got this angle, you know, for example, you're looking for the area of sector OBC. So it has to be 1 by 2 r square theta, but we do not have the angle over here. So what I'm going to do, I'm just going to calculate for the part 3. For the part 3, I'm just going to write 1 by 2 r square theta. R square was 3.4 square times it by theta. And I'm going to keep it equal to, since the ratio was 3 and 2, right? So I'm just going to multiply 1.78 by 3 and 2. So by just sorting it down, this 2 can be cancelled out by this 2, and theta has to be 1.78 times 3 divided by 3.4 ka square. So by just solving it down, I'll be having the final theta, and that final theta comes out to be 0.462 in radians. So what does that mean? That this angle has to be 0.462 radians. And as soon as I've got this angle, I just need to calculate the perimeter of the badge. And how I'll be calculating the perimeter of the badge, I need this side, right? I need this side, right? I need this side, and I need this side. So I've already got this side and this side. This has to be 3.4 as well. The two things which I need to calculate would be the side OA, which I can calculate by just simply using the, what do you call it, the cosine rule. And then I'll calculate the side BC by just using L is equals to R theta. So if I'm looking for the perimeter in the fourth part, the only thing that I'm going to do is to calculate OA first. So OA has to be, OA has to be, you're looking for OA. So it has to be the sum of the other sides, like OB square plus OC square minus 2 times OB OC times cosine of the angle, the opposite angle, right? The angle between the two sides, which was pi minus pi by 6 minus 2.034. So I'm just going to replug the values now. So OA has to be the square root of OB. If you remember, the OB was something like 3.4 square. OC was something like 1.9 square minus 2 times 3.4 times 1.9 times cos pi minus pi by 6 minus 2.034. So by just getting myself the final thing, you can just simply calculate the square root of all this thing. So you'll be having 2.1 centimeters. So that is how you'll calculate OA. And now if you want to calculate the length of the arc BC, so now you can see that we also need to calculate the length of the arc BC. We've got 3.4 and we've got this angle as well. So I'm just gonna replug these values. So, L must be equal to R theta. R was 3.4 and theta, if you remember, was 0.462. So when you're gonna times them up, you would just be having 1.57. At the end of the day, we're looking for the perimeter. So how would you get the perimeter? You've got the side OA, which came out to be something like, we just got that, and that came out to be 2.1. 2.1. We've got the other side that was 1.9, then 3.4, and the length of the arc was something we just calculated. Okay, now we have got this question number 9, and we have got this curve. This one is a quadratic curve, then there is a straight line, and then there is a trigonometric curve. So first of all, in the A part, we need to express 6x minus 27x minus 27 upon 4 minus x square, and we need to write it in this form, right? So first of all, I'm just gonna, just write it down. So for the first part, I've got 6x minus 27 upon 4 y is equals to 6x minus 27 upon 4 minus x square, if I'm not wrong. Okay, I've got this expression. Now I'm just going to write it in a completing square form. So I would be having negative 27 by 4 negative x square plus 6x, which can be further written as y is equals to negative 27 upon 4, negative as common, and you'll be left out with x square minus 6x. Now I'm just going to do the completing square thingy. So minus 27 upon 4, negative, bracket, x minus 3 square, and then minus 9. Now I'm just going to solve it down. So I would be having y is equals to negative 27 by 4 minus x minus 3 ka square, and then plus 9. And as we all know that negative 27 plus 4 upon 4 plus 9, it has to be something like 36 upon 4. 36, 4 nines are 36. Yeah, it has to be 36 minus 27, which is something like 9 by 4 minus x minus 3 ka square. So that is the expression or the quadratic expression that we've been looking for. Right after this quadratic expression, uh, we just need to find the maximum point on C1, which is the P. So we just wrote this expression to look like 9 by 4 minus x minus 3 ka square. By completing it with a standard form, you can already see that the maximum has to be 3 and 9 by 4. If you're going to compare it with a standard form, the maximum has to be 3 and 9 by 4. Now, getting to the question number, figure number 2, also shows part of a sketch where curve C2 with equation y is equals to cos x, kx, where k is a constant and x is measured in radians. Given that C1 and C2 intersects on the x-axis at the points A and B, you can see that A and B are the mutual points of intersection or the x-intercepts of the curve as well. So by just having this equation and getting yourself two values of x would get you A and B. The smaller one should be A, the bigger one should be B. So if he's asking us to get the x coordinate of B, I'm just going to equate my completed square form equals to 0. 9 by 4 minus x minus 3 square equals to 0. And now I would be having from this equation 9 by 4 equals to x minus 3 square. Taking the square root on both the sides, I would be having x negative 3 equals to plus minus 3 by 2. And now I'm just going to split it down, and I would have two values of x, and that is going to be 3 plus 3 by 2, and x equals to uh, 3 minus 3 by 2. So from here onwards, I would be having 9 by 2. And from here, I would be having 2 times 3, which is 6. 6 minus 3 has to be 3. So I would be having 3 by 2. So what does that mean? That the x coordinate of B was the bigger thingy, and that has to be 9 by 2. So we both get to know that this A has to be 3 by 2. This B has to be 9 by 2. So we have got these things. And now he's asking us for the value of K. How can we get the value of K? By just plugging any of these points, A or B, into the equation of the trigonometric equation given. So I'm just going to use A, which is 3 by 2 and 0. And I'm going to plug that value in that equation. So for the fourth part, I've got an equation which is y is equals to cos k x. Y would be 0. Cos k would be, x has to be 3 by 2 over here. And then what I'm going to do, I'm just going to calculate cos inverse of 0 equals to 3k upon 2. And I would be having, everybody knows that cos inverse of 0 has to be pi by 2 equals to 3k by 2. This 2 and this k cancels out, and k comes out to be pi upon 3. So that is how we'll get the value of k, right? And once we've got the value of k, he's asking us to calculate the period of C2. So I'm just going to rewrite this equation. Everybody knows that the period of cos x is 2 pi. So for the fifth part, y is equals to cos k comes out to be pi by 3. So that equation would become cos pi x upon 3. Now, we know that whatever the cos function is, pi upon 3x, it has to be added into 2 pi. because the period of cos is 2 pi. So now I need to make x over here. So what I'm going to do, I'm just going to multiply cos pi by 3 as it is. And since I need to take 3 as common as well, pi is already common, but I need 3 out as well. So I'm going to multiply it by 3 and divide it by 3. And now I'm just going to rewrite it as y is equals to cos x as common, sorry, not x, pi as common. And I'll be left out with pi by 3 as common, and I'll be left out with x plus 6. So what does that mean? What is getting added into x? That is 6. So the period of this equation has to be 6. So that is how we're going to solve this question. Now, getting back to this equation in the last part, the line segment L joins P and B. So you've got both the points of line L. So first of all, you need to get yourself the equation of line L1, right? You need to get yourself the equation of line L1. The coordinates of P were, if I'm not wrong, the P was 3 and 9 by 4. So P is 3 and 9 by 4. And if you're looking for B, the coordinates of B has to be 9 by 2 and 0. So first of all, I'll get myself the gradient of this line. So the gradient has to be 9 by 4 minus 0, which is 9 by 4. And then 3 minus 9 by 2, which is negative 4.5. So I would be having 9 by 4 divided by negative 1.5. And now it comes out to be 9. And 4 times 1.5 has to be something like 6. So that would eventually become 6 negative. And the gradient of this line would become negative 3 by 2. So at the end of the day, the equation of this line, I'm just going to use using point slope form. I'm just going to use y minus y1. You can see that the y1 has to be, I'm taking y1 as. So you can see that you've got this equation over here, y minus y1, which has to be 0, equals to, the gradient of that equation was negative 3 by 2. So you've got negative 3 by 2 x minus x1. X was 9 by 2, right? So I'm just going to write this equation down. So y would be equal to negative 3 by 2x plus 3 times 9 is 27, 27 upon 4. So it would be 27 upon 4. So now you've got all these equations. Now what he says in the last part, use inequalities to define the region R. You just need to talk about the region R. You can see that this region R lies beneath the curve of the quadratic function. So the first region that is going to define it has to be y. The first region that has to define it has to be y. You can see that less than 6x minus 27 upon 4 minus x square. Apart from that, you can see that this region also lies beneath the line, right? So the other equation or other inequality that defines this region has to be y less than negative 3 by 2 x plus 27 upon 4. At the end of the day, you can see that this region is lying above the curve, right? Above the curve of the quadratic function. So the third region that defines this region has to be y greater than cos 1 by 3 pi x. Is that clear? So that is how we're going to talk about these 3 points. Thank you very much.